On to our last page of notes. Our last page of notes is very similar to what we've been going through this whole time, except now we're talking about the ratios of perimeters. So what this theorem is for perimeters is that if two polygons are similar, then the ratio of the perimeters is equal to the ratio of their corresponding sides. So their scale factor. If you know the scale factor, you know this perimeters ratio as well. So the ratios have to be the same. They have to be the same. So, as you can see, 3 and 6 is 1/2. 4 and 8 is 1/2. And 5 and 10 is 1/2. So they all have a scale factor of 1/2. Their proportion, their ratio. Well, that's determined with the perimeters. As you can see from this, we can add 3 plus 4 plus 5, which equals 12. And we're gonna, for ABC, triangle, and triangle DEF is 6 plus 8 plus 10, which equals 24. And we've been going from ABC to DEF. We can see that their perimeters, 12 over 24, is the same thing as 1/2. So it says that if the two polygons are similar and they have a scale factor ratio, then the perimeter also has that same ratio. So it's the same thing. So, looking at example 9, if the ratio of the perimeter of a rectangle, ABCD, to the perimeter of a rectangle EFGH is 6,5. So we have the perimeter to a perimeter of 6,5. What is AD to EH? So looking at it, it says this ABCD is similar to, I'm better at drawing, not on the fly, EFGH, and their perimeters are similar to each other. And it says AD to EH. How are they going to be proportionate? Well, if the perimeter of the ratio is 6,5, then the ratio of the sides is 6,5. That's how that works. So now consider if HD over DC has a ratio of 3 over 4, and the perimeter of the rectangle EFGH is 15. We can determine the perimeter of the rectangle ABCD. Well, HG correlates with this one, so that means 3 over 4 has to equal 15 over our unknown, since DC and DC here, perimeter. So we just have another proportion. We knew the ratio of the side lengths, and we know one of the perimeters. We can determine the other perimeter because they have to have the same ratio. So once again, we are cross multiplying. We get 4 times 15 equal to 3x. So 3x equals 60. And when you divide by 3, you're going to get 20. So the perimeter for ABCD is 20. All because this ratio has to match the perimeters ratio. So we can determine missing perimeters and or side lengths. Okay. So just a few more problems and we are done for the week. Okay. Almost there. Okay. So we have example 10 to go through. And this works very similar. So we have two lovely rectangles that are similar to each other. And we want to find the 3 questions it's asking. First off, the measure angle R. I would like you to actually find the measure of angle S. Angle S is better. So to determine how we're going to start solving for all of this, well, AB. Do you remember our proportions from triangles? If we know AB, then it has to be similar to QR. So we have these two being similar to each other. BC is similar to RS. CD is similar to ST, therefore QT is similar to AD. So that at least helps us determine where our proportion's at because they are not the exact same. Now that we have that, look at S. What is S similar to? S is similar to which letter in ABCD? Well, it's the third away, so it has to be similar to C. C is 110 degrees, therefore S has to be 110 degrees. Remembering our lovely triangle characteristics, it also works with rectangles. Well, we need to find perimeters, but QRST only has one number, and ABCD only has two. Well, let's look at that. Since this is a lovely rectangular parallelogram, AB is 20, therefore CD must also be 20. AD is 10, therefore BC is also 10. So we can figure out the perimeter of ABCD. So we're going to add 20, 10, 20, and 10, which is going to equal 60. So we know the perimeter of ABCD to be 60. And we also know that TS is equivalent to DC, which we just said is 20. So sweet, we can write a proportion. So looking at this, we have our three lines of 20 and 10. So we have 20 over 10 has to equal the perimeter where our 20 was, 60 over our unknown QRST. Now it's just a proportion, same thing. So we're gonna cross multiply. We're gonna get 20x equal to 600. And we need to get x all by itself, so we divide by 20. And x is gonna equal 30. So what that means is QRST has a perimeter of 30. There we go, that's not too terrible. And now it's asking, what's the scale factor? Okay, well, we now have our perimeters, so we can use our perimeters, or we can use the two side lengths that we knew we could set them equal to. So we're gonna do that one. So we're gonna see that 20 over 10 simplified, because we have to have scale factor as simplified as possible, is 2. Our scale factor is 2. All right, well, example 11 has 3 parts, and if you would like to take a moment, see if you can figure out what they're asking, go ahead, pause the video, and then continue. If not, please follow along. These are the last few examples that we have to do for this week. So example 11. We are going to find the scale factor. Okay, well, first off, they all look pretty similar, right? We got the same angles, and we can see that. But let's assume they are similar. Do I have to find every single one of them? No. But we can, we wish. So FJ has to be the same thing as ZW. So we can see that 16 over 20, and scale factor says it has to be the simplified ratio. So we're going to simplify 16 over 20 to be 4 over 5. So that should be our scale factor. So we're going to check one more just in case. We're going to check 24 and 30, since they have to be the same as well, since they are in the exact same position. Well, you can both divide them by 6, and you're going to get the fact that this is 4 over 5. So once again, your scale factor should be 4/5. So that's nice. B, can you determine if these two are similar? If they are, what is their scale factor? So first off, we have 6, 8, 6 and 8, 3, 6, 3 and 6. You should always go with the smallest numbers together. So we should see that 6 and 3 should be related, and 8 and 6 should be related. So let's first go with 6 and 3. 6 over 3's proportion simplifies down to 2. And 8 over 6 is going to simplify down to 3 halves. Are these the same number? No. So since these are not the same number, they are not similar, and therefore do not have a scale factor. Okay, remember remember how to do those. And our last example for today. Our triangle DEF is similar to triangle MNP. Find X. So we should know that the sides should be proportional to each other. So 9 and 12, 12 and 16, and X and 20 should be proportional to each other. I'm going to go with the smaller numbers of 9 and 12. So we're going to take 9 over 12. And we want to find X. So it should equal X over 20. Now that we have our proportion, we can solve for X by cross multiplying. So we're going to get 9 times 20 equals 12X. 9 times 20 is 180 equal to 12X. We divide by 12, therefore X has to equal 15. All right. Again, it's a little weird being through lecture through video, but please make sure to answer any problems that you need. I will happily answer them on Monday. You can email me at any time. Thank you.